Hi there guys. So this is just another video on calculus, finding the derivative using the rule. But this time, we don't have easy functions. As you can see, these functions are a bit more complicated, as well as this expression over here, but we'll get to that. Let's start with the first one. So we have brackets in this first function, and I'm going to show you how to first multiply the brackets out and then take the derivative, because as it stands, we can't derive it like that unless you know some advanced calculus. So let's multiply the brackets out. X times x squared gives us x cubed. Then this x squared times the 2 give us 2x squared. Negative 3 times x is negative 3x. And negative 3 times 2 is negative 6. Okay, so now when we take the derivative, I should remember to write this notation. Once we take the derivative, we're going to take our exponent, multiply it by the number in front, and then decrease the exponent by 1. So this becomes 3x squared. That becomes 4x. This is only the negative 3, and the negative 6 simply becomes 0. So we stop there. Right. Question number 2. We have a y function. So before I'm going to derive this, I first want to simplify this fraction. Okay, I want to have separate terms like we have here. Okay, so I'm going to divide the the x to the power 4 by this, and I'm going to divide the 4 by that as well. Okay, so x to the power 4 divided by 2x squared, that is basically, so if we divide the x's, we must minus the exponents. So this becomes 1 over 2, okay, because there's invisible 1 there. And then we'll have x squared as a numerator. Now, because it's a numerator, I'm just writing it next to the fraction. Okay, the numerator is implied because this is simply x over 1. So next we have 4 divided by this. Now 4 divided by 2 is simply 2, right? So we have a 2 as a numerator. And this x squared, I kind of want to bring it to the top. So it then becomes x to the power of negative 2. Okay, so whenever you take an expression like that to the top, the sign of the exponent should change. Okay, so that's what I've done. And now only I can take the derivative. So as it stands, this is still y, but over here, I'm going to say dy over dx. Okay, I'm taking the derivative now. Now, this 2 multiplied by that half gives us a 1. So we have 1x to the power of 1. Okay, here we multiply the negative 2 with the 2. So we have negative 4x to the power of, now if I minus 1 to a negative exponent, that makes it further negative. So therefore we have negative 3. Minus 2 minus 1 is negative 3. Okay, again, this is not expressed in the form that we want it, so I want to write this as a base to the power of an exponent. So how do we write a third as a fractional exponent? Well, I'm going to put the inside exponent on top and the outside exponent at the bottom. So we have x to the power of 4 over 3. Okay, and here the inside number is 1 and the outside number is 2, so the square root of x is simply x to the power of 1 over 2 to the power of a half. Okay, so now when we do the derivative, I multiply the exponent with the number in front, and then I minus 1 to the 4 over 3, so that gives us 1 over 3. Okay, then I do the same here, multiply a half with the number in front, and I minus 1 from that half. Okay, so a half minus 1 gives us negative a half. Okay, question number 4. So here we have an operator. That's what I'm going to call this, an operator. It's like multiplication is an operator or division is an operator. This operator tells us that we need to derive the function that's inside. But before we can derive the function that's inside, I'm first going to rewrite it in a way that's easier for me to find the derivative. So let's keep that over there because I'm not taking the derivative just yet. First, I want to rewrite this as x to the power of a third. And then I'm going to say divided by x to the power of 1. Now, when you divide variables with the same base, you can minus the exponents. So if I minus a third by 1, I end up with, x to the power of negative 2 over 3. Okay, so this is the thing that I'm going to derive now, which then gives me, and now I don't have to write this dx with the brackets. I can simply write the answer, which is going to be negative 2 over 3 x to the power of, if I minus 1 to that, I get negative 5 over 3. And that's your final answer.